All right, time for another DraftPhysics.com, DebatePhysics.com also, but no one will show up for the debate. So it appears the Dr. John whatever, scientist, some sort of teacher who's now decided to make an internet career. Anyway, yes, well, he deleted my reply link, and so I guess I'll take that as his answer that he's not going to in any way participate in the debate or the conversation. So I will post what I sent as an email offering him, fair compensation for his time, and apparently he just won't provide. He won't defend his physics. It's that simple. You can't pay them to defend the science they're preaching. And they're preaching it. They're not teaching it. They're preaching it. And it's just crap. And so, well, this is a crap video. Okay, so I found this. Yeah, I can point that way, and it's the right way now. Interesting. Played with the background just to try to create some continuity in how I see what's actually being published. And that way, maybe I won't make as many little technical mistakes. But who knows? I don't know if I like this angle. Mine looks better. So that's good. All right, so let's, I guess we'll go get to it, right? We'll play some of this. It's just such crap. You just, how do even videos like this get made? So part of it is, look, all these videos are, partially in Hindi. Okay, I mean, it's hard to call it English. I mean, nothing, look, it's great that people are bilingual, but it really does make it difficult.
Types of potential energy. Gravitational potential energy.
So he just repeats words he just puts on the screen. So you're just saying, what audience is this made for? I mean, realistically, it's so bad.
Objective. To understand gravitational potential energy as a type of potential energy.
So this whole idea of potential energy, like again, the example would be they'd say something has potential energy. So I have a boat on the side of a stream, okay, the side of the Mississippi River. I have a boat on the ground beside the Mississippi River, and they'll say, well, the boat has potential energy. Well, no, it doesn't. It doesn't have anything. I have to put it in the water, and the water has to act on it. There's no potential energy just being somewhere in space. You have to allow the force to act, to change, And so I could have the boat tied to the shore, and they'd say, oh yeah, the boat has lots of potential energy. Well, it's tied to the shore. It's not going to go anywhere. I mean, it's just such a wrong way to, in my opinion, describe the physical reality. It's clearly a force. You clearly put things in the force, and then you let them go. Okay, you have them tied to your hands like a boat. They can't go downstream, and then you let them go, and they can go down the stream, right? Clearly the appropriate metaphor.
Energy is the capacity to do any work.
Right, so any work means anything that creates other things that move. So energy is just when you transfer whatever you have and give it to something else. That's all. All you can do is transfer energy. There is nothing else. There's just transferring. You can put it in a battery, you can put it in a spring, you can put it lots of different places, or you can lose it in lots of different places, but it's just moving from one place to another place to another place. So this is something figured out 350 years ago, and physicists won't say it.
Potential energy is a form of energy that an object possesses by virtue of its position.
So that's kind of silly, right? I mean, the position doesn't give a battery potential energy, right? I mean, a battery can be full of electricity, and it has lots of potential energy, and nobody's going to sit there and say it has something to do with its position. Its position isn't its potential energy. Same with the spring, compressed spring. Yes, you could argue it's the two ends of the spring's position, but obviously I could use some other form, okay, I'm just trying to think of a non-compression storage, flywheel. It's certainly not the position of the flywheel. I mean, obviously the position of the elements of the the movement. But again, you're talking about actually storing movement. And the reason why the battery is violating the rules is basically because the movement's inside of the chemistry. Duh. It's just how small the particles are that are moving. So if you make very small particles move in a circular manner, that is, in a manner that doesn't allow them to fly a certain distance, they have to bounce off the interior, you can create quite a bit of energy. So air pressure would be a good example. Okay, there's no real position change. You're really creating a velocity change.
Another way to think of it is as stored energy that is ready or has the potential to do work.
I guess I shouldn't have said a velocity change, because you're really changing the volume in which the velocity can move. Okay.
Potential energy can be one of three types: gravitational, elastic, or chemical.
And again, there's probably other types like nuclear. This is just such a cheap version of science.
In this session, we'll focus only on gravitational. Gravitational potential energy is the energy that's within an object when...
So it says within the object. So obviously it's not within the object until the object is given motion. So any potential has to be realized over time. You have to allow something to gain velocity before it gains the energy. So I mean, it's that's another obvious point, that clearly it doesn't have all of all potential, and they're just measuring something based on where you arbitrarily place the ground. It's just too silly.
It is moved against a gravitational force. If an object is raised above the ground, it will acquire potential energy.
So this is really vague, which is just the funny part, right? Because they're going to say there's an explicit formula for this, and yet he's not going to say anything explicit, because frankly it would sound stupid.
Object's gravitational potential energy will depend on its weight as well as how high it is above a surface. A heavier object will have more gravitational potential energy.
All right, so it doesn't have any, and it just really has to allow the gravity to now act on it without it being... The gravitational potential energy it has when it's just sitting on the table is obviously putting weight on the table. The earth has to push the table back up, so obviously some work is being done, and it's just silly to say it's not doing anything until you drop it. And the fact is, there's a certain amount of force, stream pressure, so this is essentially a bowling ball tied to the shore, or an anchor, and all the force is going to the anchor. All right, and then you're going to release the anchor and allow the stream to now move the ball. And the fact is, it's a big, heavy ball. It's going to collect more force because it's bigger. And so, yes, for the stream, it's the amount of surface area you apply. And then for other things, it's going to be just your mass. Okay, and so gravity is a very tiny, discrete force. It hits you based on your mass. Your mass is your sail. Okay, so it's not like your surface area is your sail. It's your mass that's the sail. But, same idea.
Consider a large bowling ball and a small baseball that are dropped into identical buckets of...
So you can just understand that one of them has a big giant sail, one of them has a little tiny sail. Obviously, if they were blowing in the wind, one of them's going to collect more, wind than the other one. So the bowling ball makes a big splash because now it's going to lose all of that energy it collected, and the water's going to now have that energy. It's that simple. It's transferring the energy to the ground through the water first.
Of water from the same height. The larger ball will cause more water to splash out of the bucket than the smaller baseball. An object's potential energy will increase when there is an increase in its height above a surface.
So they know their formula says it's 2 to 1. So, it's, I make it twice the height, I get twice as much energy. That's what their MGH clearly states. Twice the height, twice the energy. He won't say that. He just goes, oh, he gets more. When, if he had to say it, then he'd have to be stuck with, this nonsense. So I'll put in this nonsense part here just to demonstrate what the implications are of what they're saying. And it's just plain silly. MGH is incorrect. It is not accurate. It doesn't describe reality. So, I should be able to do this part better now, because I can see, I could maybe even write by looking at the camera. Well, I won't bother doing that. Simple, this is their theory, right? I have a scale, all right, and I have an object, 1 pound, and I have 1 pound over here, baseball, doesn't matter. I put one of them on the scale, okay, and now I have stored in the spring, okay, because the spring compresses. In that compression, I have 1 unit of energy, okay, 1. That's what I've accomplished. We're just going to call the amount of compression that creates 1 unit. And then I just do the same exact thing. I put this one on, I get 2 units of compression, okay, it compresses twice as much, okay, not 4 times as much, just twice as much. But the physics claims, okay, MGH says, I now have 4 units of energy. So even though I only compressed the spring twice as much, and I did exactly the same action, somehow when I move this one on, I get 1 unit of energy. When I do exactly the same thing and put a second one on, I get 3 units of energy. That's their physics. And as stated, it's as ludicrous as any kind of notion that it takes 25 times the fuel to go 5 times faster. To spin a motor 5 times faster, their physics says it takes 25 times the fuel. That's what it says. That's what it says. Do you believe that could possibly be true? So lie to me and tell me you believe that's true. Go ahead. Go ahead and lie to me and tell me you believe that's true. That it takes 25 times the gas to, if you drive to the store at 10 miles an hour or you drive to the store at 50 miles an hour, you'll use 25 times the gas going 50 miles an hour. Sure you will. Assuming you're driving for the same amount of time. So you're going a little bit longer route, doing the 50 miles an hour. I have to put in some condition that obviously you're gaining some benefit by getting there sooner, but you're clearly not going to use 25 times the fuel. All right, anyway. So, just saying, can you make sense out of that? I do 2 equal amounts of work, and I double the amount of energy I get. Quadruple. I do, it's hard to make sense out of this idea that I can do just the same act. The spring compresses, indicating I did just that. I just added another pound. I only have 2 pounds of pressure. And you're basically saying I have 4 pounds of pressure. It doesn't make any sense. It's not the truth. And they just keep preaching it. All right. Back to the video. So here you see the big cop-out. He won't say it. This guy won't say it.
Now imagine that we have 2 balls of the same size being dropped into identical buckets of water. The one being dropped from the higher point will
So he just says higher point. It's clearly twice as high, but whatever. He won't use the explicit statement they would make. So he's not going to tell you, well, the one that's twice as high is going to make it's going to make this much larger splash. I shouldn't say much larger. He won't tell you exactly how much of a splash.
Possess more gravitational potential energy, and so will do more work, creating a bigger splash.
So obviously they may look like twice the splash. That won't be twice, because that's not how gravity works. clearly the velocity won't be twice the velocity when it hits the water. It won't hit with twice the weight, because to do any of that, you have to go 4 times higher. Because gravity is a time-dependent force. It depends on how much time you're in the wind, decides how much wind you collect. How much time you're in a stream decides how much the stream pushes you. It's a real mechanical force. It's not some, even if you think it's some sort of not real thing, like magic, it still has rules. And the rules are mimicking water and mimicking wind and mimicking any other thing that has a rate of it passing through a specific area. It works exactly the same way. It obeys the exact same rules.
Water stored behind a dam or at the top of a waterfall has gravitational potential energy.
So that's a vague, again, statement where, again, they're arguing it takes 25 times the water to spin the wheel 5 times faster.
Summary. Energy is the capacity to do any work. Potential energy is the energy that an object possesses by the virtue of its position.
So again, it's just such a silly thing to say, because guess what? That's only true based on the kind of force, and there's only a correlation that's consistent depending on the force, and it just doesn't work in the sense that there's clearly no one-to-one relationship between distance and how much energy you're going to acquire, as Galileo proved. 1, 3, 5, 7. Obviously, the amount of distance you travel per unit of force collected is going to be dependent on how long you're in the force. Oh, God.
Potential energy can be one of 3 types: gravitational, elastic, or chemical.
Or nuclear. I mean, really, you can push electrons or protons closer to each other and create energy, potential energy. So they should include it.
Gravitational potential energy is the energy that's within an object when it is moved against a gravitational force.
So again, moved against a gravitational force only works if you're actually incurring, again, more force because you're in it for a specific amount of time. And again, it's just the amount of time you're in it. And if nothing's taking the force away from you, then you're going to fall in it. And if you're not going to fall, if you're going to go not fall, then you have to overcome all of that falling pressure. So if the force is pushing you down and you want to go up, you have to undo all of the down before you can even start to go up. So there's another very bad video. So yeah, they put their little like and subscribe crap like this. Anybody should be recommending this nonsense, this trivial pile of nothing. Yuck. It's terrible. So I'll play another garbage video. Alright, I am back. So leave us play this video. So let's understand this, what the nature of gravity is, that is what the nature of forces are and how they act on matter. This was argued for 100 years, this distinction between momentum and kinetic energy. And it's clear what the history is, that the Newtonians and the Descartians believed in momentum, okay, and that the Leibnizians believed in this mv squared. And here they are. Why are they perverting that truth? Why are they pretending this is Newton's formula when it's Leibniz's formula? Why are they doing that? You'd think they'd want to revere their hero, Leibniz, who actually, wasn't credited at all with invention of this marvelous, tool of, fake energy, frankly. Very fake.
Gravitational potential
Jesus Christ.
molar of gravitational potential energy and applications of gravitational potential energy. Before starting the lecture, click.
Yeah, I mean, it'd be really nice if we had an international language and, we decided on a world language. It's about time. But whatever. Because, yeah, this is rough. I mean, it's kind of funny, though. I mean, it's funny that, this guy obviously speaks he understands English. He just can't speak English. He can't enunciate the words anywhere close to good enough.
On the subscribe button and get access to our 100 of conceptual lectures for free. Firstly, understanding the easy concept of gravitational potential energy. Let's consider an object present on the Earth's surface or ground. I am interested to raise this object to the point A. So I do some sort of work on this object
And what you're really overcoming is the amount of force that would be pushing you down. So you have to overcome the down and then apply an up. But, continuing. The Earth is now relieved, okay? So when it was on the Earth was doing the work of keeping it in its position. So now you're, having to do the work the Earth was doing, plus the added work, okay, of going even further into the gravity.
it
Upstream.
gains vertical height h. Now if I release this object from the point A, it will accelerate by itself to
Right, and it'll accelerate by a Galilean formula of, just one tiny unit of distance, then 3 units of distance, then 5 units of distance, then 7 units of distance per a unit of time. So in 1 second, it just does one little tiny bit of distance, and then the second it does 3 units of distance, and in the third second, it does 5 units of distance.
towards the earth or ground. From this example, we learn that if we want to raise or lift up an object above the ground, we need to do some sort of work on that particular object.
You have to put force, you're countering a force, you have to counter a force with a force, so you have to apply force.
Secondly, an object above the ground has potential to accelerate or to fall.
It only has potential, again, because you've taken away the thing that was going to hold it up against the gravity, and you've moved that a certain distance away, and you're just going to sit there and let it free fall. So if there's no counter force, then it will be acquiring the energy of the force. It can't acquire it if you're holding it against the force. So there's nothing holding it against the force. It will fall based on the force's pressure, and it's all that's going to matter is how long is it falling in the pressure.
Down towards the ground due to gravitational force. This falling potential of an object due to gravitational force is called gravitational potential energy. Let me repeat it.
Oh dear, don't do that. That would be horrible.
This falling potential of an object due to gravitational force is called gravitational potential energy.
That's what you call it. Okay. I call it going downstream.
Thus we learn that an object,
Getting blown by the force, whatever.
if left up or raised above the ground, possesses gravitational potential energy. For example, the airplane moving above the ground possesses
It's sort of a bad example because obviously it's doing all of that buoyancy stuff in terms of pushing air.
gravitational potential energy. The birds flying above the ground possesses gravitational potential energy. The kite above
Teeth were made to indulge. Remove
So
the
bad.
traces of stains in 2 weeks with Colgate Optic White
And then you have a
Plus toothpaste.
commercial, 2 commercials. Yeah, for this
above the ground.
for this crap. Okay. All of these are so bad as examples just because of the fact that it's, air is going to pervert how they fall.
Possesses gravitational potential energy, and a man standing on a tall building possesses gravitational potential energy.
So none of this possessing of anything. The boat doesn't possess any energy while it's tied to the shore. It doesn't possess anything. All of the energy is leaking out of it through the tight rope.
Thus, anything above the Earth's surface possesses gravitational potential energy. Now, let me derive the expression or formula of gravitational potential energy. Well, let's consider that a ball is present on the ground. Let the mass of this ball is m. I exert vertical force F on this ball. As a result,
So if you exert vertical force F, so what does that mean? Did you apply a force, instantaneous type force? I mean, a jolting force? Or are you going to slowly apply a force over a length of time? So which one? So there's no distinction here. So I mean, the obvious argument is if you use a slingshot or some device to give it velocity very quickly, then the energy it has, okay, will allow it to reach a potential. But you could pick it up very slowly and lift it very slowly, and there you're going to be having to do the work of holding it against the force. You're going to be acquiring its gravitational energy, and it's going to go through you and into the ground.
the ball moves in upward direction and gains vertical height h. We know that work done is equal to force and
So we don't know that. So this is work. I don't know what the dot D equals, but anyway, it's work equals force times distance, and it's really force times time. So obviously 9.8 meters per second, okay, is clearly telling you there's a rate of force being applied. And then you could argue that you could just apply a certain amount of joules of energy to some object and propel it very quickly over a very tiny amount of time and give it a lot of energy, like an explosive or something.
into distance. Here, I have done some sort of work on this ball because I exert force.
Some kind of work doesn't, again, this is saying absolutely nothing. So clearly not an experiment of any kind where they actually measure the amount of work done. So nothing stated there. Again, if I lifted barbells over a 3-hour period and I just slowly lifted it, I'm going to do a lot more work than if I just lift it in 1 second.
F on the ball and it covered vertical distance h. So work done on the ball is equal to F into h.
So this is a huge cheat. Okay, so it only applies in this circumstance, and obviously the h isn't going to tell you the actual amount of work you're going to do. No experiment is going to show that. This is again them saying that somehow twice the velocity is 4 times the work or force.
I replace d by h because here the ball covers vertical distance h.
And again, it's in a force that's time dependent, 9.8 meters per second. So we know that when it lifted off, you did this, you did 3 units of distance before you hit half your velocity. It's just a fact. You can just measure where's half the velocity going to be. It sort of has to be exactly at the same distance that if you gave something 1 velocity. So if you had 2 balls here and one of them was just 1 velocity and the other one's twice the velocity, you can understand that the 1 velocity is a certain distance. It goes a certain height against gravity. Well, I just take that height and I transfer it over here. I should draw it that way. I don't think I've exactly made the argument in those terms, so it's an argument I made over and over again, but I haven't made it this particular way, so we'll draw that. Alright, so the simple experiment is you're going to launch something into the air. And if I have 1 velocity and 2 velocity, same mass. And so if I give it 1 velocity, it goes a certain height and stops. I give it 2 velocity, it goes that height, and then it goes this height, and then it goes this height, and it goes this height. Now their formula explicitly says it only goes to here. Okay, twice the height, twice the velocity. Alright, but the simple argument to make is we know this is what 1 velocity looks like. So we did this experiment. We can see what 1 velocity looks like. It looks like this. Alright, that's all. That's what it looks like. So if we look at this, we don't need to measure where it's going, one velocity, because we know exactly what one velocity looks like. It looks like this right here. Okay, this is one velocity. So we know, okay, that, well, I shouldn't have put it there because I'm taking one of the notches out. So let me just put extra notches in here. All right. So we know that this is exactly what one velocity looks like. So we know it's going half the speed. I mean, you know, 3/4 of the way down the track. And so this whole thing, and if we measure it by time, we'll find out this is 1 unit of time, this is 1 unit of time, and all of this is 1 unit of time. And it's clearly telling you this tail here. And again, this velocity that you're left with is only 2 velocity, and you went 4 times the distance. The same thing's going to happen when you're going back down. All right? You're only going to collect 1 unit of energy here, and then a second unit of energy force here. 1 force here, okay, 1 force here. Because your velocity you've already acquired isn't helping. I mean, it isn't going to make you collect more force. The only thing that's going to make you collect more force is the time you're spending in the force. The time the force has to act on you. 9.8 meters per 1 second. That's Newton. Newton isn't this nonsense. Oh, I didn't need to pause. Yeah, I need to hit the play button. Okay, do that.
Let I call this equation number 1. We know that mass of the ball...
So we don't know any of this. They're preaching it. Okay, so this, in my opinion, this is just an obvious Holy Ghost pile of nonsense. Newton explicitly said that the force equals your velocity. Apply twice the force, go twice as fast. Apply 3 times the force, go 3 times as fast. He made it clear. Force is velocity. It's equal. If we just leave mass out of it and say masses aren't changing, you'll get a complete transfer of force into velocity. And clearly height isn't going to give you, you have to have twice as much height to get 1 unit of force, 1 unit of velocity.
Is m. According to Newton's second law, F...
So this isn't Newton's law. Newton didn't say it. Newton didn't write it. It's not his law. It's not his physics. This isn't the second law at all. Again, the second law is explicitly saying there's a complete and equal correlation between the force and velocity. The two of them aren't just proportional. They're equal to each other. A force is momentum, and you're clearly just transferring momentum to the object. 1 unit per 1 unit.
is equal to ma. It means
He
that...
didn't say it. He didn't say it. He didn't say it.
When I exert force F on the ball of mass m, the ball accelerates in vertical direction. We also know that when this ball falls,
It's going to be exactly the same energy given back, okay? What goes up comes back down with the same energy you applied to have it rise. And, clearly it's going to go the same velocity you launched it at, or if you're applying a constant force, it's the same force you applied to overcome the gravity.
down, its gravitational acceleration is constant, which is represented...
Constant by what kind of standard? Constant in time. You can't say it's constant and then not say something like, well, of course, 1 second you get this much, 1 second you get this much, 1 second you get this much, 1 second you get this much. You can't say the word constant without it having to mean it has to be happening per some unit of time. And Newton explicitly used the second. So yes, second seems a perfectly rational thing to use. So yes, it's 9.8 meters per each second. Each 1 second unit of time, you're going to gain 9.8 meters of velocity or force. The velocity equals the force. So in 2 seconds, you'll gain 2 units of force. In 3 seconds, you gain 3 units of force. That's Newton's physics. This is Leibnizian physics. It's just a lie to keep saying this crap. This is a slander to Isaac Newton. It's not his physics. I mean, it's explicitly not his physics. I don't know why people are defending lying about it. So if you're going to defend this physics, at least acknowledge that you can't do it from the position where you're already lying about who said it. If you can't even do that honestly, how can anything else you say mean anything? You won't even honestly admit it's not Newton's physics.
By small g. So
small g is 9.8 meters per 1 second, not 9.8 meters per seconds or per second squared. It's 9.8 meters per 1 second.
Instead of a, I will put g in this equation.
Yeah, see, and then they start doing these sloppy replacements that are just a gigantic, huge cheat. All right, because that's clearly not what Newton said.
I get f is
Stacy's pita chips.
More of
Good
that
shit.
crap.
Parrot. Try now.
No.
I have to finish it. We don't let anybody stop us.
is equal to mg. Let I call this equation number 2.
So it wouldn't be a terrible thing if it was mass times 9.8 meters per 1 second. So if they had g correct, this wouldn't be that offensive. But they don't. So it's bullshit.
Now I will put equation number 2 and equation number 1.
Yeah, well, that makes no sense at all. Fuck.
Or I will put
So we know the work equation was garbage anyway, so he changed the D into an H. Now he's going to change the F into mg.
the value of force in this equation. I get work done is equal to mgh.
Okay, and when it's actually mgt, you only get 2 units of time, 2 units of velocity, 2 units of weight. So you drop it from 4 times the height, it's just going to be, 2 plus 2 plus 2. There's no 4s. Okay, twice the force is all you're going to have.
So our work done stored in this ball as mgh. Let me repeat it.
No, don't do that. Please, don't do that.
Our work done stored
Alvalden, okay, so I don't know what an Alvalden is, but whatever.
in this ball as mgh. In physics, we call this
I call it bullshit. Physics dishonestly calls it some sort of verified physics, which it isn't. It doesn't survive the simplest test. It fails simple tests. Go ahead, drop balls and see. You'll fail to work.
mgh is gravitational potential energy.
And it isn't. And it doesn't work. It gets the wrong answer. And it certainly doesn't get the answer Newton would get. So if you ask Newton, how much energy does the ball have? I lifted it 4 times the height, and I dropped it. And you ask Isaac Newton, how much energy does it have? He's going to say twice as much energy. If you ask Isaac Newton, if you drop 4 pounds 1 foot, or you drop 1 pound 4 feet, he's going to say they're not the same. Okay, the 1 pound drop 4 feet has half the energy.
So the ball above the ground at this point possesses gravitational potential energy. If I ask you why this ball possesses gravitational potential energy,
Because it's in a force differential that happens constantly, which means at a rate in time. Certain amount of it per millisecond, billionths of a second, doesn't matter what. There's a certain amount of applied change to the object. And it's constant. The same amount of change happens every billionth of a second, every trillionth of a second, every million bazillionth of a second. It all happens at a rate.
at this point, your answer will be
And how fast you are running through it or towards it or away from it doesn't really matter, except when you're going against it. And that's the fact. You're just going to collect it. So it's like wind. If you push against the wind with your sail, you're going to have to do more work. If you go with the wind, the wind will do the work for you.
Because I have done some sort of work on this ball in order to lift it up above the ground.
And it'll be the same work that the ball's going to do going back down to the ground.
And this wordens
But it won't be the same work if you aren't traveling the same velocity. So if you change the velocity, you will change the amount of work you'll have to do. So if you go up very slowly and let the ball drop very quickly, the ball will do less work. You will do a lot more work.
stored in the ball as gravitational potential energy. Therefore, we define gravitational potential energy as
I didn't watch this part, so this will be the fun surprises.
energy stored in an object due to its position.
So again, this nonsense about position. The position is only relevant because position provides an opportunity for you to fall in a unit of time. So position gives you time. That's all. The time is what matters. The time is where the force is collected because it's a constant force. A constant amount per a constant unit for any unit of time. Per second. In Newton's case, per 1 second. 9.8 meters per 1 second. That's Newton's physics, not this garbage.
About the Earth's surface. Let me repeat it. Energy
It's really about your distance from the center of the Earth, but you can't fall to the center of the Earth because the Earth is in the way.
stored in an object due to its position above the Earth's surface. Note down that in the formula of gravitational potential energy, m is mass of the ball, which is constant.
Let's see if he draws hg as the actual formula, which is 9.8 meters per 1 second, not 9.8 meters per seconds.
G is the gravitational acceleration, which is
Yeah, let's see if he says
9.8 meter
per second squared. There he did it again. So they just keep lying. So obviously Newton did not say that. He did not say 9.8 meters per second squared. That's not Newton's formula. It's not what Newton said. Newton explicitly said, nope, it's 9.8 meters per 1 second. Each individual second you get 9.8. Exactly as Galileo predicts, and Newton and Descartes, they all agree, and you're just all a bunch of Leibnizians and you just won't admit it. That's not Newton's formula. It's not Newton's physics. This is just lying over and over. They just all lie. I mean, and none of them will account for the lie. None of them will say, yes, okay, we know this isn't what Newton said. It's not Newton's physics, but we're going to just rewrite Newton's physics for Newton.
per second squared. And it is also
Any painter can paint.
Oh, barf. I'll just pause. Yeah. Fuck. He says it's a constant.
h is the vertical height of the ball above
Which is the distance, which doesn't make any sense. Distance doesn't matter, especially if you already have a velocity going in. If I have a velocity going in, then this formula won't work, because I'll zoom right through the gravity, and the distance will be moot, because it's about how much time you allow the force to act.
the ground. So gravitational potential energy depends only upon the height of an object.
Bullshit.
Here, let me ask you. Let's consider two balls of
Why don't you consider a real experiment that you could show it actually happening?
same masses above the ground. Let the height of this ball is 10 meter and the height of this ball is 20 meter.
Yeah, so not drawn very well, obviously. So he's going to tell us, okay, frankly, that this is going to have twice the energy, when obviously it can't have twice the energy because it can't be going twice the speed, and it's just no chance.
Which ball possesses more gravitational potential energy? Well, we have learned that gravitational potential energy depends upon the vertical height.
So it won't weigh twice as much when it hits the ground, right? It won't be going twice the velocity, obviously. And it won't take twice the time.
The height of this ball is 20 meter. So this ball possesses more gravitational potential energy
Well, how much more?
than this ball. That's why we have to do a lot of work or provide
So he didn't do any proving math here at all. Didn't give us the answer to the question, right? He tells us the math for absolutely, and the meters for absolutely no reason. Because he doesn't expect us to calculate the answer. Because the answer will be bullshit.
a lot of energy to a satellite to send it to the space. Finally, let me teach you the applications of gravitational potential energy.
So we know the space shuttle is a really bad example because most of the fuel has to be used to plow through the atmosphere. The atmosphere is the big problem.
We know that water is stored in dams at a certain height above the ground. This stored water possesses gravitational potential energy. When these water fall down, its
It's got to wait for gravity to act on it.
gravitational potential energy gradually converts to kinetic.
You're right. It gradually converts. Yeah, because the gravity has to act on it. Amazing. So whatever this is, this kinetic energy. So the kinetic energy is the idea that you put 1 pound on a scale and it's only 1 unit of energy. Then you put another pound on the scale and all of a sudden now you have 4 units of energy. Even though you only did 2 units of work, you have 4 units of energy. Yeah, I don't think you do. Bad science.
Energy. The kinetic energy of the water runs the turbine and generate electricity. So by the help of gravitational potential
I don't think they do this old steam engine thing. So I really don't think that's how they run the turbine. How they collect the energy. They spin magnets and directly convert it into electricity.
energy of water, we generate electricity. This was all about gravitational potential energy.
And it's all about lying about one of the greatest scientists in human history and just completely blow up everything he said. Just sit there and distort it and pervert it. His second law says, okay, force equals the change in your velocity. That's what it says. And his third law says equal and opposite reactions, which kinetic energy destroys any sense of equal and opposite reactions. The bullet has 2,000 joules, the gun recoil has 2. That's hardly an equal and opposite reaction. Absolute crapola. Oh, I guess that's it. Just nice little music to end with. Jesus. Oh, I just hate this planet. And then nothing. Okay. And then we have the little pop-ups of all the other wonderful crap you can see on this shitty, cruddy, crappy channel of bullshit. Alright. How charming. Not. Alright, so that's enough. So I don't need to draw anything else, right? I mean, it's just been over it and over it. It's just all lies about Isaac Newton. And their scientists are proud to lie about, again, one of the greatest physicists, scientists, plainly, in the history of mankind. And they'll just lie about what he thought and what he said. They'll distort and pervert his science into absolute crap and nonsense. For what reason? Because they're afraid to say they're Leibnizians and that they disagree with Newton? Are they afraid to disagree with Newton? Even after all these years, they're afraid to say Newton was wrong? Well, have the integrity to say Newton was wrong. But they don't have that integrity. You can't pay them to have it. You can't humiliate them to have it. Because they're scummy humans. And that's the truth. Humans are pretty much made of scum. You could just have an equation: human equals scum times shit. You know, that's what a human equals. All right. So till the next time, and such and such.